Hey, welcome to another Automat DEVLOG. Today I will try to talk a little bit about how we do debugging. Typically, debuggers are composed of two parts. There is a tracer process, so this is the debugger, and there is a tracy process. This is the debugged application. This is also the case in Automat. When we compile assembly to machine code, we execute it in a separate thread. We call this just the worker thread. The tracer in Automat's nomenclature is called the control thread. Most debuggers have this property where either debugger executes or the tracy executes. Tracer sets some breakpoints and lets the tracy execute. And this is because Linux, I'm familiar with debugging on Linux mostly. We will work on Windows, but we are starting with Linux. Linux has a wait-PID system call, which is used by tracers to wait until an event happens in the tracy process. The problem with wait-PID is that this option has no timeout, so it's hard to react to other events while you are waiting. When a thread blocks in wait-PID, it's pretty much locked. It has to wait until something happens in the tracy. Debuggers which want to have some interactive execution, they usually employ some extra helper thread. Okay, I have to admit something, I'm not sure how it's done in most debuggers, this is how it's done in Automat. Here we have an extra thread, and the extra thread serves as the source of interruptions. When the tracer is locked, it's waiting for an event to happen in tracy, and tracy is running. External thread can send signals to the tracy to stop it, so that the tracer can take control and do something. Let's call this signaler. And this is actually how Automat also works. So when it has machine code that executes in memory, this is our machine code that executes in memory, every frame we want to get a snapshot of the registers so that we can display them on screen. So this is where signaler sends a signal to tracy, which then wakes up the tracer. And this allows us to get the value of registers. So this is one model of thread execution that we decided to follow here. There are actually other ways to do this. I'm very tempted to do the other approach, and the way it would work, let me quickly describe this here, would be that there would be no control thread and no worker thread. Instead, we would have machine code being executed directly on the caller thread. We are not using any extra threads. When you execute machine code, you just jump into machine code. It starts executing right away. So the main thread executes machine code. And let me show machine code as something. Say this is machine code. So main thread starts executing right away and it blocks until machine code finishes. It would kind of lock up the thread, right? Not quite. Because in Automat, most execution happens on auxiliary threads. In this model, the machine code is actually slightly different. Normally, the machine code doesn't need to have any facilities to read registers. This is the job of operating system, of the tracer. It calls ptrace and gets the values of registers. In this model, the machine code is different because it contains entry and exit points that take all of the registers and serialize them to known addresses in memory. So this is our machine code, but with register persistence. This sort of machine code is slightly more complex. When we emit this kind of machine code, we have to pay more attention to the assembly that we generate. Essentially, it has more logic inside. It contains the debugger logic intertwined with the machine code. When an event happens, we still have to stop the assembly, because if assembly is stuck in a loop, infinite loop, then we still need to somehow signal it. And this is actually what we could use signals for. So there would still be signaler thread in this approach. The signaler would just wake the machine thread and tell it to serialize the register. This could be even faster because it involves less system calls. It's an alternative architecture that in the end I didn't implement, but maybe I will, who knows, if you have some time. So far, this debugging at 60 FPS, this works. This is what Automat has, and this is what we will develop more this week. Okay, that's it for today. See you next week. Bye.